Before we come to the next case, let me just tell you what these lines are that I've shown. You can see that there are these contours, and they're actually used to show the horizontal velocity component. The thick lines indicate positive u components, which means the flow goes to the right. Okay, you can see that here near the surface. And the dashed lines, the thin lines, tell you where the component is negative, so the flow goes to the left here near the surface. And at depth, you can actually see a return flow. So there's water coming back here from the left, below this pattern here on one side, from the right on the other. Okay, this tells you something about the dynamics. Now let's have a look what happens if you switch on the Coriolis force. Here we go. After 24 hours, 36 hours, 60 hours, you still have that pattern sitting there. The low density, the light patch still hangs around the surface. And what these lines now show here is actually the currents which are into the page or out of the page. These ones are geostrophic flows created by the pressure gradients that go into the page or out of the page. Okay? So this pattern doesn't have currents which actually move to the left or to the right into the X. Okay, if you also look at the animation, you see that actually that pattern itself wobbles around. It increases a little bit the radius and then decreases. These are so-called inertial oscillations. Anyway, let's have a look. You see these oscillations, inertial oscillations? And the pattern that we actually simulate here is something that we call an ocean eddy. It's a circular pattern, and you just cut through that in the middle. And in reality, these patterns are circular and the currents move around them. You just cut through the middle of them. So in this process, we call it a geostrophic adjustment. Geostrophic features are these processes which are driven by pressure gradient, but controlled or balanced by the Coriolis. So this is what you can do with a 2.5 dimensional ocean slice.